Hello, and welcome to our lesson on converting fractions into recurring decimals. In this lesson, our primary focus will be on understanding how to convert fractions into recurring decimals. We'll break this down into manageable steps. We'll start by demonstrating the process of converting simple fractions into recurring decimals. We will then explore some fractions that convert into more complex recurring decimals. Finally, we'll apply this new knowledge through a series of practice cases to reinforce our understanding. In our previous lessons, we've built a strong foundation by discussing how to convert recurring decimals into fractions. With this foundation, we can now explore the reverse process of converting fractions into recurring decimals. Let's get started. Before we get into the technique, let's quickly review what we already know. A fraction is a way of representing a part of a whole and is written in the form of a numerator and a denominator. For example, 1 over 3 or 2 over 9. A decimal is a way of writing numbers that can have parts of a whole, represented using a decimal point, for example 0.5 or 0.75. A recurring decimal is a decimal number in which one or more digits repeat infinitely. For example, in 0.3333, the digit 3 repeats indefinitely. To understand this process, let's convert the fraction 1/3 into a recurring decimal. The goal is to use long division to perform this conversion. First, we divide the numerator by the denominator. Set up the division problem, 1 divided by 3. Now ask yourself, how many times does 3 go into 1? It doesn't. So we write 0 and write in the decimal point, making it 1.000. Now continue the division until you notice a recurring pattern. Remember to write in the remainder of 1. Now we need to divide 10 by 3. 3 goes into 10 3 times, leaving a remainder of 1 again. Repeat the division, 10 divided by 3 is 3, remainder 1. Notice the remainder is still 1, which means we have 10 again. This process repeats indefinitely, showing that the decimal representation is 0.3333, continuing forever. As we move down each position from our initial divider, which was looking at the units column, to then looking at the tenths, hundredths, thousandths, etc., each time the answer was 3 remainder 1, so we can see that this would repeat forever. We denote the repeating part using a dot over the digit. Convert 2 over 9 to a decimal. Set up the division 2 divided by 9. 9 goes into 2 0 times with remainder 2, so write 0 and write in the decimal point, making it 2.000. Remember to write in the remainder of 2, so we next need to divide 20 by 9. 9 goes into 22 times, leaving a remainder of 2. Repeat the process with the remainder 2, which brings down to 20 again, resulting in 0.2222 or 0.2 recurring. Now let's convert 5 over 6 to a decimal. Set up the division 5 divided by 6. 6 goes into 5 0 times with remainder 5, so write 0 and bring down the decimal point, making it 5.000. This step tells us that the units column will be 0. 6 goes into 58 times, leaving a remainder of 2. This tells us that 8 is the value of the tenths column. 6 goes into 23 times, leaving a remainder of 2. Therefore, 3 is the value of the hundredths column. Repeat the process with the remainder 2, which brings down to 20 again, resulting in 0.8333 or 0.83 recurring. To make it clear, this initial division, before we had moved any decimals, gives us the 0 in the units column. Then this second division, where we had taken a decimal place to make it 50, gives us 8 for the tenths column. Finally, this division, after we had taken 2 decimal places using our remainder, gives us a 3 for the hundredths column. Now let's try a more complex example. Convert 2 over 7 to a decimal. First, set up the long division for 2 divided by 7. 7 goes into 2 0 times, so we write 0. Add a decimal point to the quotient and a 0 to 2, making it 20. 7 goes into 22 times, so we write 2 in the quotient and get a remainder of 6. Add another 0, making it 60. 7 goes into 68 times, so we write 8 and get a remainder of 4. Continue this process adding zeros and dividing until we see the pattern repeat. The remainders and quotients will eventually repeat, giving us the recurring decimal 0.285714. By using dots over both the 2 and 4 in this number, we show that this whole section repeats. By identifying repeating remainders, you can determine the recurring sequences in the decimal representation. In today's lesson, we explored the process of converting fractions into recurring decimals, an essential skill in mathematics. We began with a quick review of basic concepts including fractions, decimals, and recurring decimals to ensure a solid foundational understanding. We then proceeded with a step-by-step demonstration of converting the fraction 1/3 into its recurring decimal form using long division. This process revealed the decimal representation 0.3 recurring, illustrating the repeating nature of the decimal. This lesson emphasized the importance of recognizing patterns in numbers and provided practical techniques for converting fractions into their decimal forms, equipping you with valuable tools for solving mathematical problems. Watch the rest of the GCSE Maths course at Sophos Education.